up, pack it in, let me begin. I came to win, battle me, that's a sin. I won't ever slack up, punk, you better back up. Try and play the role and you're the whole crew.
Well, welcome back. Our topic today is called Factorable trig equations, and I have to give a quick shout out to my two homeboys this week, the Saucy Rossi and Sick Daddy, and let's get started today. So, factorable trig equations. Let me just remind you of some quick factoring techniques. Okay, first of all, we have everybody's favorite GCF factoring. For example, if I said 4x squared minus 3x equals 0, I could easily factor this bad boy with a GCF. Basically, I'm going to look at both terms and see what they have in common. I would say they both have an x in common. And when we say GCF, remember, we're going to divide out the x. So when I do that, I still have a 4x minus a 3. And then, of course, if I wanted to tee that up, I'd just split it between those two. I'm setting each section equal to 0. All right, so there's our GCF factoring. Let's take it a little further. And we have what we call factoring trinomials. Basically, where we have three terms. So let's say we have x squared minus x minus 6 equals 0. I can easily factor this bad boy. A lot of algebra teachers will say something like factor in the AM. So feel free to put your AM there, like morning AM. That means you're adding to this term here and multiplying to this term here. So we usually start with our multiplying, and you just ask yourself what multiplies to 6. Well, you can either go with 1 times 6 or 2 times 3. At this point, I would then look at those two numbers and say, okay, which one adds to a, of course there's a 1 there, a negative 1. Well, 1 and 6 can make 7 if you add them, and I'm thinking, a 5 if you add or subtract, obviously maybe a positive 5 or a negative 5. 2 and 3, if you add them, you can get 5, and if you subtract, you can get a 1 or a negative 1. So there's my winners there. So I'm going to say x with a 3, x with a 2, and then a quick check. Remember, your outsides make the 2x, your insides make a 3x. You want a negative x when you add them. That means the 3 term would be negative, and this guy would be positive. Of course, I would set each of those equal to 0, and tee it up and factor as well. My last set of factoring for you is going to be trinomials, but it's that guess and check factor with trinomials. Okay, so let me give you this bear. 2x squared minus 5x plus 3 equals 0. Okay, now remember, guess and check is still going to nicely factor. You just kind of have to guess at the number. So, I'm still going to say factor in the AM here, but I like to call this one MAM, M-A-M. So I'm multiplying to this, adding to this, multiplying to this. So let's start with our first multiplying. 2 is fairly nice. Your only options are 2 and 1. And my other multiplying is fairly nice. My options are 3 and 1. Now it just depends, do I put the 1 here and the 3 here? Or does the 3 go here and the 1 go here? And that's kind of the guess and check part. So let's see, if I leave them here, that will get me a 6x, and this will get me a 1x. Can you get a negative 5 out of those? Well, if I wanted a negative 5, this bear would have to be negative, and this bear would have to be positive. Now, you might be thinking that's great and that works, but that doesn't multiply to positive 3. So this actually does not work. Okay, because again, a positive times a negative is a negative, not a positive. So let me reverse those numbers and let me put my 3 here and my 1 here. Now on my outside I've got a 2x, and on my inside I've got a 3x. Can I get a negative 5? Well, I certainly can if they're both negative. So this sign would have to be negative, and this sign would have to be negative. Now, when you multiply a negative and a negative, you get a positive. So there's kind of my guess and check. And now I can easily solve and tee this one up. All right, question 1. Tangent squared x minus 3 equals 0. And notice they give us this domain 0 to pi. So basically, all my answers have to fall between there. Now, let me simplify this for you. Maybe it looks intimidating. If I were just to call tan x x and say x squared minus 3 equals 0, could we easily solve this equation? Well, I would think so. I would add 3 to both sides, so I get x squared equals 3. And then ask yourself, how do you get rid of a square? What undoes a square? And if you ever forget, throw on the same button on your calculator. Basically, you would just take the square root of both sides. Now, one catch to watch here. Every time you physically put your own square root in, you have to remember to put a plus and minus sign in as well. So I would get x equals plus and minus radical 3. Now, clearly, that's not going to be my final answer to my problem because that was solving this equation. But my point was to say, as easy it is to solve that equation, it's just as easy to solve this one. So let's go ahead and actually solve the equation they want now. So instead of calling it just x, I'm calling it tangent squared x minus 3 equals 0. So I would do the same thing. I would add the 3 to both sides. Tangent squared x equals 3. And now what was our next step? We said get rid of that square, and to get rid of the square, we just simply took the square root of both sides. Now again, that plus and minus. So similar to this one, just instead of saying x equals plus and minus radical 3, I'm getting tan x equals plus or minus radical 3. Alright, so this requires just a few more steps like yesterday. I'm going to split this up and say there's two answers here. I've got tan x equals positive radical 3, and tan x equals negative radical 3. Okay, and again, that's because I have two answers here. Now I'll say, alright, what is my reference angle? Okay, so I'm tangent, I'm just a radical 3. Hopefully you're saying that angle would be 60 degrees, and I'm just going to leave it in radians, so I want my final answer in radians, which of course is equivalent to pi over 3. And now the other thing I want to slow down and get are my quadrants. I'm positive radical 3. So a quick, all students tip cows. Tangent's positive in the all and in the tangent quadrant. So I need to get an answer in quadrants 1 and 3. So in quadrant 1, my 60-degree angle, of course, is 60 degrees. In quadrant 3, if I draw in a 60-degree angle, that makes that whole quadrant to 40. Alright, now, let's go do the same thing for my negative radical 3. My reference angle is still the same. I'm still saying 60 degrees. And I'm going to put myself in the correct quadrants. All students tip cows. I need to be negative tangent, so I can either be in quadrant 2 or 4. And if I draw my 60 degrees in quadrant 2, there's my reference angle to the x-axis. That makes a total of 120. And if I draw it in 4, there's my 60 degrees. Gives me a total of 300. Now, a couple things I want to watch on my cleanup. You'll notice, if you recall, that we need to be between 0 and pi. Okay, so if I say 0 and pi, hopefully in your head you adjusted that to 0 and 180. So I can kill this answer, and I can kill this answer. So I'm basically going to have just two answers. Now, because they said 0 to pi, I want to make sure I put my answer back in radians. So my 60, I'm actually going to say is pi over 3. And 120, let's talk about a quick way. Instead of saying, well, you could say 120 times pi over 180, or ask yourself, how many 60s go into 120? Well, I would say there's two of them, and we know 60 is pi over 3. So 2 pi over 3. And there you go, we've got our first two answers. Alright, we're off to a good start. Let's try another. Number 2. Tangent x times sine squared x equals 2 tan x. And again, you'll notice they gave us this nice domain 0 to 2 pi. Okay, now what's the difference between yesterday's lesson and today's? Well, we have these squared terms. Okay, and these are quadratics, of course, which tell us we want our equation to equal 0. So I'm going to bring all this junk to one side. So tan x sine squared x minus 2 tan x equals 0. Okay? Alright, now in this problem, let me just tweak it a little bit. If I said my tan x I called x, and my sine I called y, so that would be y squared minus 2x, oops, how would you solve an equation like this? What could you do to this equation? And it comes back to that math F word of factor. You could factor an x out from here and here. And I would say that's x times y squared minus 2 equals 0. And in fact, that's what we want to do in this case. But instead of x's and y's, you basically just have tan and sine. So what does this side and this side have in common? Well, they both have the function tan x. So pull it out as a GCF. When you pull it out, remember you're dividing it out, I believe you're left with sine squared x minus 2 equals 0. And again, all I did was pull out a nice GCF. Alright, at this point, we're just going to tee her up. And so here's my two functions. I'm just going to tee in between those two. And I'm going to carefully set each one equal to 0. So on this side, it's going to say tan x equals 0. And on this side, sine squared x minus 2 equals 0. Okay, let's attack this left side here. Tan x equals 0. What goes through your head? Well, it's not 30, 60, or 45, because none of those have 0 in the chart. So that means the tangent of x equals 0 on the graph. Remember, tangent starts at 0, then at pi over 2 there's an asymptote, pi there's a 0, 3 pi over 2 there's an asymptote, 2 pi there's a 0. That's why those graphs are so important. You've got to know when and where it hits 0. So how many times does tangent x hit 0? Well, it looks like there are clearly 3 times. So I'm going to say x can equal 0, x can equal, that should be pi, and x can equal 2 pi. Alright, let's continue on the other side. So I've got a squared term, and I can't factor it because this is not a perfect square, so all I'm going to do is I'm going to bring the 2 to the other side, and ask myself, how would I get sines alone if it's squared? I would take the square root of both sides, and don't forget that plus minus. So let me split it up because I do have 2 answers. I've got sine x equals positive radical 2, and sine x equals negative radical 2. Alright, so let's go get our reference angle. Now, is this one that you should know, or are you going to have to use your calculator? Well, hopefully you know by now, radical 2 is not an answer from our table of values that we've memorized, so calculator's fair game. Now remember, to get x by itself, you're going to have to hit sine inverse of radical 2. What happens when you do that? Grab your calculator and try. I get the word error. And what is that telling me? Well, that's telling me that there's no solution here. This can't happen. Okay? And again, I just want to stress that you're not putting the negative on when you try this side. That just tells you the quadrant. So again, I'm going to hit sine inverse of radical 2, which I already know the answer, does not exist. I get that error message, no solution. So in this case, if I just check my domain, 0 to 2 pi, it looks like my answers are going to be 0, pi, and 2 pi. So let me take 20 seconds and just talk about when and where you're going to get an error, and maybe you can even catch it ahead of time. Here's the sine curve. Okay, so there's my pi over 2 pi, 3 pi over 2, 2 pi. What is the height of the sine curve? Hopefully you've said positive 1. What is the lowest height of the sine curve? Hopefully you said negative 1. If you try to take the inverse sine of any number bigger than positive 1 or smaller than negative 1, you're going to get an error. For example, if I said sine inverse of 4, well, look, the graph doesn't even reach 4. 4 would be up here. The curve only goes up to a height of 1. So this would give you an error. If you said sine inverse of 2, you're going to get the same thing because this graph only goes up to 1. It doesn't hit 2. So that will give you an error and there won't be a solution. Alrighty, question 3. 2 sine squared x plus sine x minus 1 equals 0. And we're given the domain 0 to 2 pi. So again, our answers just have to fall in there. Now this might look a little more intimidating, but watch this little trick. If I were to replace all the sine x's I see with just the variable x, for example, this would then be 2x squared plus x minus 1. Is this a problem you could solve? Well, I'd say so. You could actually solve it back in 9th grade. We just redid it again in 11th grade here, but you could solve this in 9th grade. It's just guess and check factoring. So let's set up 2 sets of parentheses, and it's a very simple one. What's the only way to get to 2x squared? 2x and x. The only way to get to 1, 1 and 1. Make your little smiley face. There's your 2x, there's your x, and you want to add in the middle to a positive x. That means the 2x would have to be positive, so I'll put my plus there, and the 1x would have to be negative. And that would give me a positive x in the middle. Now if you can do that, you can solve this problem. It's just as easy. Instead of using x's, we're going to use sines instead. Alright, so let's factor the same problem, but like I said, let's use sines instead of x's. So it's set equal to 0. We're going to do a little guess and check. Instead of saying 2x, I'm just going to say 2 sine x, and sine x, and 1 and 1. And again, I don't think I've done anything special. 2 sine times sine is 2 sine squared. 1 times 1 is 1. And just like we did before, we would check our outsides, and we said we want a positive 2 and a minus 1 in the middle to get a positive sine squared there, equals 0. Well, you've done the hard part. Now we just tee it up and set each side equal to 0. 2 sine x minus 1 equals 0, and sine x plus 1 equals 0. Okay, so this is the part that takes a few seconds. Solve for sine x. What would you do first? Well, hopefully you said add over the 1, and then divide both sides by 2. So I've got sine x equals 1/2. Okay, so now you say to yourself, I need a reference angle and I need quadrants. All students tip cows. We know sine is a positive, so I can be in the all and I can be in the sine. So I know my answers are in quadrants 1 and 2. Reference angle. When on the sine chart does it equal 1/2? Sine of 30. Excellent job. Alright, so quadrant 1, there's my 30. That stays as is, it's less than 90. Quadrant 2, remember your reference angle is to the x-axis. If that's 30, how big is your whole angle? 150. 180 minus 30. Alright, let's go get the other side. Sine x equals, I'm going to subtract over the 1, so negative 1. Now, that does not come from the table, that comes from the graph. Maybe you can mentally picture these. That's eventually what we want you to do. I'm going to draw it out for those of you that can't. And I just say to myself, sine starts at 0, then it goes to 1, 0, negative 1, 0. I don't even need to connect the curve. Just plot your points and ask yourself, how many times, first of all, does sine hit negative 1? Well, we just said 0, 1, 0, negative 1, 0. It hits it once. So there is one answer, and that, of course, is 3 pi over 2. So my x equals 3 pi over 2. Notice you're not going to have a quadrant if it's on the curve. Okay, so maybe make a note to yourself, there's no quadrant if you're on the curve. Now, do they want these in degrees or radians? And a quick check, it says 0 to 2 pi, so I'm going to quickly check these into radians. 30 we should know as pi over 6. Now ask yourself this, how many 30s go into 50? Well, 5 times 3 is 15, so that means 5 30s, which is 5 pi over 6. So I've got pi over 6, 5 pi over 6, and 3 pi over 2. Alright, so let's use our solution notation in the end and wrap them up together. Alright, here we go. It's our last one for the night. Question 4. 5 sine squared x minus 4 sine x minus 1 equals 0. Now notice these directions. Solve for x to the nearest degree. So this should tell you, this is a big deal, this should tell you you're most likely not going to know this answer. You're going to need a calculator when it says nearest degree. And they'll tell you your answers have to fall between 0 and 360. Alright, let's try factoring. So of course, it's another guess and check, of course, because we're starting with a 5. And I think it's a pretty friendly one. So pause it, try it on your own, see what you get. So I went with 5 sine and sine for my first terms, 1 and 1 for my last. I need a negative 4 in the middle. So I've got a 5 sine x and a sine x, and the only way to get a negative 4 would be for this to be positive, or negative, and this to be positive. So I want that negative and that positive. And if you got that, then again, you did the hard part of factoring, and now we'll just tee it up and solve both sides. So 5 sine x plus 1 equals 0, and sine x minus 1 equals 0. Alright, solve for sine x. So I would subtract 1, and then divide by 5. Okay, so here's where we really have to slow down. Let's get our quadrants. All students tip cows. I'm sine and I'm negative. So they're all positive here, and sine is positive here. That means my two answers should be in quadrant 3 and quadrant 4, first of all. Now, I need to go get the reference angle, and we stressed this the other day. Do not put in the negative sign. Okay, so here's what I'm doing on my calculator. I am typing sine inverse of positive 1/5. Okay, the negative sign just tells you the quadrants. And to the nearest degree, I get 12 degrees, which of course is my reference angle. Not my answer, but my reference angle. So how do I go get those? Well, I draw my 12 degrees in the third quadrant, and I ask myself, what is that whole arc that I made? Well, that looks like a 180 plus 12, which is a 192. And then I'll draw my 12 degrees in the fourth quadrant, and I'll say, what is that whole arc? And that would be 360 minus 12, which of course is a 348. All right, now I'm going to go do the same thing on the other side here. I had sine x minus 1 equals 0, so sine x equals 1. Now again, this is one you should know. It's not from your chart, because it's not a 30, 60, 45 answer. It's a 1 or a 0, which comes from the graph. So let's put our points out, equals 0, 1, 0, negative 1, 0. How many times did we say positive 1? Well, I would say once at pi over 2. Okay? Now, do they want the answer in degrees or radians? Well, I believe it said degrees, so I'm going to say pi is really 180 divided by 2, which of course is 90 degrees. So I've got a total of 3 answers. I've got 90 degrees, 192 degrees, and 348 degrees. Well, there you have it for our factorable trig equations. We'll see you tomorrow. Have a great night.